Good morning and welcome everybody to the Smart Snippets for Synthetic Surfaces. I have the pleasure today of being joined by Jared Hill, Director at SportEng, who we do the vast majority of all our synthetic surfaces with. Jared's got a long history of natural, hybrid and synthetic engineering surfaces. And what we're talking about today is the importance of having the right drainage strategy. Now, the concept of drainage underneath a synthetic field is to make sure we can take the water away from the surface as quickly as possible. Now, FIFA, World Rugby, AFL, Rugby League, they all have constraints about how quick the water gets taken away vertically through the grass. So when the rain comes down from the sky, so to speak, it has to vertically go through the grass, the rubber infill, the sand, and the shot pad. What happens then is really down to the importance of the drainage cell. And there's two kinds of drainage, which Jared is going to take us through. One is a vertical drainage, and then the second one is a horizontal drainage. Both of these are relevant to underneath the pitch, not on top of the pitch. So we don't want any drainage of the water on the top of the pitch, it's all underneath. So Jared, welcome and thank you for joining us. And can you just explain the difference now between the vertical and then the horizontal?
Yeah, morning, Martin. Thank you for the opportunity to talk on really an important part of the synthetic project. As you alluded to, there are two different systems, the horizontal drainage system and a vertical drainage system. The horizontal drainage system requires a typical road base profile, so a heavily compacted crushed rock base, which is impermeable. So as you alluded to, the water will pass through the synthetic system and will come into contact with that crushed rock base that doesn't allow any water through it. So we need to create a horizontal void space to allow the water to pass through. And that void space is often in the shape of a drainage cell, which is a proprietary product, which can effectively and efficiently move the water horizontally through the plane of the synthetic surface pitch. And at the perimeter, there needs to be some sort of subsurface infrastructure in the shape of either a trench grate or a slotted pipe that can collect it at the perimeter of the pitch and move that to the drainage network. The benefits of that type of system is that you're building on a road-based pavement, so you know the design life of that pavement because the engineering principles allow you to understand the compactive effort put into that profile to ensure longevity of your profile. The limit, and also there is a efficient water flow horizontally as long as there's adequate grade on your surface. The other system that you made reference to was a vertical draining system. So once the water passes through the synthetic system, it then passes through a free draining aggregate layer. So it doesn't have a lot of fines in it, so it's a crushed rock, nominal size or a varying size of rock that allows the water to pass vertically through that, and then in a series of potentially what we call French drains, which is the subgrade is shaped to have some subterranean swales, which then have slotted pipes in the bottom of that, which then collect the water and move it through those pipes and again into a perimeter trunk drainage network. As opposed to the horizontal drainage system, the vertical drainage system, because it is made up of a free draining aggregate base, it's very difficult to ascertain the design life of it because it's not a true engineered pavement. So there are examples of it being used for long term, but from an engineering practice, because we can't heavily compact it, it's a little bit of an unknown in regards to the design life of that type of pavement.
So Jared, you talked before about the horizontal drainage, and we're seeing more of that. When it passes through the surface of the performance surface, the grass, and it goes through the shot pad, is there normally something underneath the drainage cell so it doesn't go into the crushed rock drainage? The crushed rock base?
Yeah, there's a benefit of potentially putting an impermeable membrane over the top of that, which helps the water move more efficiently horizontal. There are examples of it not being there because the crushed rock is still impervious, but the inclusion of that membrane does improve the performance of the system.
And we talked earlier on about being on a slight slope to allow gravity to take the water away to the sides. And that's normally around 0.8% of a roll?
Yeah, ideally you wouldn't have a grade any grade across the pitch greater than 1%, because that then impacts on the performance of the surface. So your drainage cell and associated network needs to accommodate the grade of less than 1%. So when you're doing your calculations, particularly for a horizontal drainage system, ensure you've got enough depth in your void space within the drainage cell to accommodate the rain event. So the drainage cells do come in varying sizes. So if you're in a part of Australia or in the world that has a large rainfall intensity, you may in fact need a slightly thicker or deeper drainage cell than you might in other parts of the country.
Yeah, you raise a good point there, because we actually ask, as you know, in our specs, for them to identify the annual rain event they want to accommodate in the drainage. And what that does is it stops people putting in, for instance, a 10 mil drainage cell when really they need a 30 mil drainage cell.
Yep.
So it really should be linked to the annual rain event that you've got. And then that should also be linked to your ability of your stormwater to take that rain event away. If it can't take it away, what are the other options available to a client?
Yeah, well, there's probably a conversation to have even before that around if you're replacing a natural turf grass field with synthetic grass field, you're suddenly going from a fairly pervious system to an impervious system. So your amount of runoff is going to be higher. So often a lot of councils will require the post-development runoff from the pitch to be the same as the pre-development. And as I alluded to, you're going to have a greater amount of runoff from a synthetic surface. So you will need to build in some level of detention within the profile or the design stormwater system. So that's where a vertical system does become beneficial. Having that void space within the drainage cell allows you to build in some storage within the profile and effectively choke the drainage outfall. So you have a little bit of build up within that drainage gravel before it is discharged. In the sense, if you do a horizontal drainage system, you need to find other ways to create that storage, whether in oversized pipework at the perimeter or a buried tank outside the footprint of the pitch.
So if the stormwater can take the water away at the same speed that it's going to be coming off the field, that's okay. It's only if philosophically the council either can't cope with that, or philosophically wants to hold the water and make sure that it doesn't flood the local area or the drainage channels, isn't it?
Yeah. I mean, what we're finding with a lot of stormwater drainage networks is that they're already at capacity. If you're wanting to add more to it, you're going to be putting downstream infrastructure under stress.
I think that's the key bit, isn't it? That when you've got heavy rainfall, not only on the field, you've actually got it to all the other stormwater around it. So you've got to take that into account. It's not just the 8,500 square meters of the grass. Just one other thing I always think it's worth looking at here as well is that one of the key issues nowadays is on microplastics. And so we've now moved away on the drainage solutions from the above ground channels to now everything being below ground, because that now stops or significantly reduces the amount of infill that would get into the drainage. You got any views on that?
Yeah, so what we now design our systems is what's called a closed drainage system. So to prevent microplastics being dispersed, we have no infrastructure, drainage infrastructure breaking daylight. So it's all beneath the synthetic carpet system. So there is an element of filtration. So no water that hits the surface can enter the drainage system without going through the synthetic backing system and the shock pad, which prevents that larger microplastic particles from being dispersed. So it is definitely something that is being considered. And even further downstream, you can incorporate some other filters within the drainage pitch to help capture some of that microplastic as well.
Yeah, that's really good. Listen, Jared, thank you very much for spending a bit of time and sharing your insights with us. We really appreciate it. Thanks, mate. Bye.
My pleasure. Thanks, Martin. Thank you.